While you are practicing assigning states of matter, solubility, and an electrolyte type to the various compounds, you'll probably want to have a copy of the solubility rules handy. The content page gives you a few versions, a stripped down version that's probably easier to use when you're memorizing, and a more elaborate version that actually tells you what the right answer is for both states of matter and solubility. It doesn't include the type of electrolyte, but you can still determine that from these charts. Compounds that will be assigned solid as their state of matter are going to be insoluble and therefore are going to be considered non-electrolytes. Compounds that are aqueous and should be assigned an AQ as their state of matter are a little less straightforward, as we will give both completely soluble and partially soluble compounds an AQ in a balanced equation. You'll have to go beyond the state of matter to determine if the compound is soluble here and is therefore a strong electrolyte, or if the compound is partially soluble here and is therefore a weak electrolyte. I will use the more elaborate chart for this video. Keep in mind as I go through this example that there are really 3 different questions asking 3 different but very closely related things, and that I use the same chart for all 3 prompts. Also keep in mind that come quiz time, you will not have access to any set of solubility rules as you're taking your quiz. While it's reasonable that you use one of these charts during practice, you need to do so in such a way that you can eliminate your reliability on it. Begin by learning the always soluble ions. These will get you through a good portion of the questions that you see. Know that the A students will also learn the rest of the rules and the exceptions to these rules. So it really is worth your time to learn these. It's not the hardest thing you'll ever do. Chemistry students have done it successfully for years, and you can as well. When a soluble salt is placed in water, the salt dissociates into its ions. When an insoluble salt is placed in water, it remains as a solid. We can look to the ions present in the salt to make a prediction of what type of compound we might have. In general, solubility charts don't contain a whole lot of cations. You'll often see ammonium in the group 1 cations, but not much beyond that. So when locating a rule in a solubility table, you'll likely need to start by looking up the anion. For our first example, that would be the sulfide anion. The rule for sulfides and hydroxides are that they are usually soluble, but always make sure you don't have an exception to your rule. While there are exceptions to this rule, and while silver is listed as an exception elsewhere, it's not an exception here. So silver sulfide is insoluble in water. It will remain a solid in solution. For barium chloride, you'll find the halide rule, which states that most halides are soluble. There are some very notable exceptions to this rule that will show up lots of times on all of the exams and quizzes, but none of these exceptions are barium. So barium chloride would be soluble and therefore an aqueous compound. Most carbonates are going to be insoluble. The only exceptions are the always rule cations, so magnesium carbonate is insoluble and will remain a solid in solution. Lead compounds are often insoluble, but always rules are always rules for a reason. There will be no exceptions to them. So lead nitrate is a soluble aqueous compound. We were asked in the first set of compounds whether they were soluble or not. The solubility of a compound determines the states of matter that should be included with them. So think of this prompt as the reasonable follow-up to the previous prompt. This should go smoothly as I included states of matter for the other prompt, knowing that this was coming. Sulfate compounds are generally soluble. However, lead is listed as an exception to the solubility rule, which means we probably need to include whatever is the opposite of the rule here, or solid. That said, lead sulfate is a tricky one. It is sparingly soluble and sometimes shows up as an aqueous compound in tables such as these. I tend to think of it as a solid, but this could be one that could be argued either way. And it's really the only compound here that you can argue with me. Potassium is an always rule. If you learned your always rules, then you're all done. You shouldn't even need to turn to the chart for group 1 and ammonium cations. Know that these are always soluble and always listed as AQ. Hydroxide compounds are generally insoluble. Since magnesium isn't listed as an exception, magnesium hydroxide will remain a solid when placed in water. Chromate compounds are also generally insoluble. The only exceptions will be compounds that contain your always rules cations, and calcium isn't one of those cations. So calcium chromate will remain a solid when placed in water. Compounds are determined to be soluble or insoluble based on whether they are able to dissociate when placed in water. We can also describe solubility based on whether a compound is a non, weak, or strong electrolyte. Non-electrolytes do not dissociate, meaning they will remain a solid in water, or in other words, they are insoluble. Weak electrolytes partially dissociate, but they do dissociate a little, so they're considered partially soluble. This means that only a portion of the sample will fall apart once placed in water, but that portion is large enough that we have to consider those ions when thinking about things chemically. Since we have to think about the ions, we list these as aqueous in our balanced equations and just keep track of the fact that they're only partially soluble. Strong electrolytes will no longer be compounds in solution. They will completely dissociate into ions because they are completely soluble. When you move beyond this question and keep practicing solubility, try to answer all three of these prompts for any compound that you're given. It'll be harder for me to goof you up with wording come quiz day. Now, on to your compounds. We've seen a halide before, and the generally soluble rule hasn't changed. This time, though, our cation is listed as an exception to the rule. So silver chloride would be a solid in water and therefore a non-electrolyte. It's still true that most hydroxides form insoluble compounds. But again, when checking the exceptions, we see that the cation given is included on the exception list. This time, being on the exception list means that our compound is partially soluble and should be listed as a weak electrolyte. It would get an AQ in a balanced equation. Acetates are included in the always rule group. There will not be any exceptions to these always rules, so this compound would be a strong electrolyte since it is soluble. Nitrates are also included in the always rule group. Again, no exceptions here, so another strong electrolyte. And lastly, the sulfates are generally insoluble. Barium is listed as a slightly soluble exception to this, making it a weak electrolyte.